Hello everyone. My name is Badr-Ud-Din. I'm with Hashmi, and today I'll be presenting my Capstone project for the IBM Data Science specialization. For this project, I've taken a dataset from the University of California Irvine Machine Learning Repository. The UC Irvine repository is widely used in universities and colleges around the world. The data set that I've chosen for this project contains information about different customers in Taiwan and tries to predict whether customers will default on their credit card payments based on 23 attributes, which are including but not limited to, for example, gender, education, marital status, and age. Moving on, I have read in the data from the CSV file using the read CSV method in Python. And if you look at the shape of the dataset, you can see that they're about 3,000, 30,000 by 25 data frame. And as we go down further, we can see before we actually extract the data and then transform it, let's have a look at the first few rows of the dataset. You can see that the first few rows have different values in the limit balance column, and the ages of the customers is also different. Right. So as I was exploring the data, I made a few observations, and that which were, for example, if you look at the education column, you can see that the and that the education column has more than four unique values, and which, but according to the documentation, we can only have values ranging from 1 to 4. And so, but we had values such as 6 and 0. So this could cause our model to not predict correctly and give a lower accuracy than initially planned. So we can overcome this problem easily by clubbing all the values that are not in range 1 to 4 into one category, and I've chosen the value 4 as that category. So as you can see below, that this graph over here has values in 4, 5, and 6, but after clubbing all the values into the others category, we can see that the fourth column now has more samples. Right. Similarly, in the marriage column, I also observed that we had one extra value, and that was of value 0. But the documentation clearly states that we can only have values 1, 2, and 3. So, just like what we did for the education column, I clubbed the 0 values into the category 3. Right. So after we're done with that, we can move on, and in the ETL process, we have already extracted the data. Now we can load the data into input and target data frames. The input data frame contains about 23 attributes with 30,000 data entries for each attribute, while the target data frame contains only one target attribute with 30,000 attributes. So let's look at the input and target values for both data frames. So yeah, those are a lot of values, right? So, but you may have noticed when we were going through the rows that we have in the first row, we can see that we have non-integer values, right? And that could adversely affect our training of a model, because the model works best on integer value, right? So we can easily get rid of the first row um, like looking at, you can look at code cell 12, which does exactly that, right? So now when we print the shape of the X and T, we can see that we have exactly 30,000 entries, right? So right. So after this, I've calculated the mean and the standard deviation of the input and target data frames. The mean of the X3 column is 1.84, which, and the standard deviation is 0.74, which makes a lot of sense because we can only have values in the range 1 to 4, right? And similarly, for the column X4, we have values 1, 2, and 3, and the standard and the mean deviation is 1.8 for the mean and 0.5 for the standard deviation, right? So which makes sense because we can those are within the range of the values we can have. Right, similarly, for the target input, we have, since we can only have values 0 or 1, the mean and standard deviation are both within that range. Okay, for now we can go on and split the input and the target into test and training sets. So now we can see I used the 80-20% percentage rule. So now we have about, since we had 30,000 entries for each column, we now have 6,000 for the test data set and 24,000 for the training data set. So now moving in the cell below, we can see that I've imported the standard scaler to transform my inputs before we actually use algorithms to train our model. And so what I've done, I've used a random forest classifier algorithm to define and train my model. Basically, I've initialized a random forest classifier. I fitted the model on the training data, and based on that I've made some prediction. And finally, I've tested the accuracy of the model on test data. I've defined my own function where basically what I did was I basically counted the number of correct samples divided by the total number of samples. And the accuracy, as it turns out, is about 80%, which is quite good. Right. So since there's always room for improvement, I decided to normalize my input data, to see if my model accuracy improves. However, normalizing the data did not actually improve the accuracy by a significant margin. At most, I think in some cases it improved by 1%, but not that much. Right, as you can see, it's quite similar. The percentage is quite similar to when the data was not normalized. Similarly, the deep learning algorithm that I used was the MLP classifier for the from the neural network class for scikit-learn. So in this case, I initialized an NP classifier model. I fitted the model on the training data, and then made some prediction, and finally test the accuracy using the true negative metric. So now we can see in this picture, I've printed the confusion metrics, and it turns out that there are about more than about 17,000 values that are in the true negative. What I mean by true negative is that metric is that the reason that I'm focused on the true negative metric is because banks need to have high confidence that their customers will not default on the credit card payments. Right, so now we have tested our model on the training data. Now let's have a look at the test data. Right, so when we print the confusion metrics of the test data, we can see there are about more than 4,000 out of 6,000 entities that are correctly predicted, right? So that brings us into the presentation. I hope you all enjoyed it, and I look forward to your feedback. Thank you, and have a nice day. Bye.